Okay, so welcome back. Now we're going to introduce another definition, but it's very similar to the definition that we talked about before, except this brings matrices and vectors into the definition. So we talked about when a solution, right? When a solution, we talked about solution sets, right? And we said that, hey, in order to be a solution, it has to satisfy all of the equations in the system, right? So now we're going to basically introduce a definition involving vectors now. Okay, so it says a linear equation. So here's our linear equation: a1 x1 plus a2 x2 plus all the way to an xn equals d. So there's our linear equation with unknowns x1 through x sub n, is satisfied by the vector, the column vector, s1 through s sub n, if, again, we substitute in the s1, right, s2 and so on, equals d. So we get a true statement, right? So that's, we talked about that before. Now, a vector satisfies a linear system if it satisfies each equation in the system. Okay, so the only difference is now we're dealing with this vector notation where the vector s represents all of these numbers, and you can look at it as like an order, an n tuple, right? We talked about n tuples, s1 through s of n. Okay, so now we're changing a little bit. We're looking at it from the point of view of a vector.